Alright, we're being asked to solve this radical equation. What we need to do first is to get rid of the radicals, or in this case the square roots. What I'm going to do first is I'm going to square both sides of this equation. I'm squaring both sides because of what's going to happen on the right hand side of this equation. When I square this, what it does is going to cancel out this square root. And so on the right hand side what I'll get is a t plus 12. Now on the left hand side things are not so nice because I have these two terms right here, and what I'm going to have to do is do some foiling. So I'm going to do that here on the left hand side. Alright, so here's that foiling going on right here, and what I've done is this square root of t plus 1 squared. I've rewritten it here as these two factors. I foiled them out, and then I combined these like terms as the square root of t to get the 2 root t that you see below. So that's what's going to appear on the left hand side of this equation now. Okay, a good question at this point is, well, what good did that do? That was a lot of work. Well, what that did was it had an equation where I started with two different terms that had square roots, and now I'm just down to one term that has a square root. What I'm going to do now is I'm going to isolate that square root of t right there, and I'm going to do that by subtracting t from both sides of the equation and subtracting 1 from both sides of the equation. When I do that, what I'll be left with on this left hand side is 2 root t equals 11. Then I'm going to simply just divide by 2 on both sides, and what I have is the square root of t equals 11 halves. Alright, now what I'm going to do is I'm going to square both sides of this equation again. And I'm doing this to get rid of this square root around the t on the left hand side of the equation. So when I square these, I get t equals 121 over 4. And there I've solved for my t. The only remaining issue is that I need to plug this value of t back into the original equation now to prove that it solves this equation. And I have to do this because of this move of squaring both sides of my equation. Anytime I do this to get rid of radicals with an even exponent, I have to always plug my values in to see if it's true. So let's do that real fast. Alright, so what I have here in the green is I've plugged this value of t equals 121 over 4 into my original equation, and I'm going to just simplify both sides here to see if they end up equaling each other out. Okay, on the left hand side, the square root of 121 over 4, that's actually 11 over 2. So I can just take the square root of both sides. I'm going to add that to 1. I'm going to write that as a 2 over 2, so I can actually add those two fractions together. On this other side, I need to find a common denominator so I can add these together. And so I'm going to write this as 48 fourths. And what I did right there, by the way, is I took this as 12 over 1 and multiplied the top and the bottom by 4 to get this common denominator of fourths. On the right or the left hand side of the equation, I'm going to add my numerators to get 13 twelfths or 13 seconds. And on the right hand side, what I'm going to get is the square root of 169 over 4. And the last move, I'm just going to take that square root on the right hand side, and what I get is that these two sides do equal, because the square root of 69 fourths is 13 halves. Again, taking the square root of the numerator and denominator separately gives me my result. That means this answer of t equals 121 over 4 is a solution to the original equation.